Welcome to another wonderful episode of Learning Chemistry. What we're going to look at right now is dimensional analysis, which is the fancy term of setting up fractions to cancel units and to put something in a different form. The first one we'll take a look at is how to go from grams of a substance, and in this case we're just working with single elements. How do we go from grams to moles? The first thing you always do in any dimensional analysis problem is you just write down what the known value is. And in this case, it's the 0.039 grams of palladium, which if we look at the periodic table, we could look around, and this one doesn't have the names on it, but the ones you'll be able to use do have the names. Palladium is element PD, which is right here. And we know that that's going to have a molar mass of 106.42 grams for every 1 mole. So we'll need that number here shortly, 106.42. So 0.039 grams of palladium, PD, but we don't want our units in grams, we want our units to be in moles. So when we set up the conversion, we're going to put grams of PD on the bottom and moles of PD on the top. We can cancel out our units to make sure that we're left with what we want, and we no longer have grams and we do have moles of PD. That's great. Now the only thing we need to do is plug in a couple of numbers. Again, looking at the periodic table for palladium, the molar mass was 106.42. So that's the number that we put right here. For every 1 mole of palladium, we have 106.42 grams of palladium. And then we put in the calculator 0.039 divided by 106.42. And the answer in scientific notation gives us 3.67 times 10 to the negative 4th moles of palladium. So that's the first example. The second example that I want to take a look at with you guys, I'm going to skip B because that's done the exact same way as A. But let's take a look at C. C is a little bit different because we have units in kilograms. But when we look at the periodic table up here, all of these values are grams per mole, not kilograms per mole. So we have to do a simple conversion. So if we start off by writing down what we know, 0.0073 kilograms of tantalum, which is Ta, we need to cancel the kilograms and go to grams. So the first thing we're going to have is the kilograms here on the bottom and the grams here on the top. So that's going to cancel our kilograms and give us grams. But we're still not done because we don't want grams, we want moles. So this time we'll put the grams on the bottom to get it to cancel, and the moles of tantalum on the top, because that's what we're going to be left with. Let's cancel our units. Those two cancel, these two cancel, and we're left with moles of tantalum. Now the only thing left is to plug in the numbers and solve. And we know that for every 1 kilogram, there's 1,000 grams. And for every 1 mole of tantalum, we would have to look at the periodic table, element Ta. And again, you guys will have a periodic table that has these values, that has the names written on it, so it's a little bit easier for you to find. Element tantalum is right here, and it's 180.947. So that's the number that would go here, 180 point, and you can round it to the hundreds place, 180.95. So in your calculator, you do 0.0073 times 1,000 divided by 180.95. A good thing to get into the habit of doing is always put parentheses in your numerator and your denominator in the calculator. It's not going to make a difference now, but when you start using exponents and scientific notation and Avogadro's number, then you'll find that you're not getting the correct answer because the logic of your calculator doing scientific notation messes the answer up a little bit. So your final answer for 1C should be 4.03 times 10 to the negative 2 moles of TA. And yes, that's the same as 0.0403 if you put it in standard notation. I will write down the answers to B and D. You can try them on your own. You can go ahead and pause it right now and try them. And if for some reason you can't get the correct answers, then come see me and we'll work on it together. But for B, it's 146.83 moles of iron. And for D, it is 5.38 times 10 to the negative 5th moles of antimony, which is the element Sb. So, good luck on that. Practice hard, and if you have any questions, come see me. But remember, it's always a great day when you can do chemistry.